Hi, my name is Kate Triano and this is my sister Emma. She will be helping me out with the experiments. Today we'll be learning about the suspension of clouds in the air and how far away a lightning strike is from your location. We will begin with learning about clouds. A normal cloud has a density of a half gram per cubic meter. Clouds can be measured with the dimensions of a shadow of a cloud when the sun is directly above it. Since clouds are very close to a cubical shape, the volume formula for a cube can be used to calculate the size of the cloud. The volume of a cube is width times length times height. The three dimensions will all have the same value. Next, you can use the formula mass equals density times volume in order to figure out the weight of the cloud. You can then convert grams to pounds. A normal cloud weighs about 500 million grams or 1.1 million pounds. In this experiment, to find the weight of a cloud, we will need cotton balls, a ruler with centimeter markings, a lamp, some strings, scissors, and computer paper. We'll use suspended cotton balls and a lamp to imitate the cloud measuring. The density of a cotton ball is 0.4 grams per cubic centimeter. We will tie a string around a cotton balls and tie it to the lamp. Now we will turn on the lamp and measure the shadow cast on this piece of paper in centimeters.
Length is 14 centimeters.
Since the cloud is as tall and thick as it is long, we will cube this measurement of length to get volume. We will multiply this volume by density of a cotton ball to get the mass of a cloud. So this cloud has a length of 14 centimeters and a density of 0.4 grams per cubic centimeters. 2,744 centimeters cubes times 0.4 grams per cubic centimeter is 1,098 grams. Next, we will investigate how a cloud can stay suspended in the air. Clouds are made up of many extremely small droplets of water and small ice crystals. These droplets and crystals are only about 1/100,000 of an inch across and create a very low density for clouds. Warm air from the surface of Earth rises and keeps these particles suspended in the air. Once the warm air cools, the water in the clouds condense and the air can no longer keep the clouds suspended. Therefore, the droplets from the clouds start to fall to Earth in the form of rain, snow, hail, or sleet. In order to experimentally prove the suspension of clouds, you will need a pot, some water, oven mitts, and a clear glass or plastic bowl. Put the pot on a stove top and set the heat to high. The water will start to boil a little bit and produce steam. Once the steam is produced, hold a clear glass or plastic bowl upside down over the steam with oven mitts. The steam will enter the bowl and become suspended in the air because of the hot air underneath it from the boiling pot of water. Once the water vapor collects in the cooler temperature bowl, it will cool and condense into water droplets on the surface of the bowl. These droplets will then fall downwards towards the stove. This is like how it rains when the warmer air becomes cool. Next, we will learn about lightning. Lightning travels at a speed of 186,000 miles per second. Therefore, we will see the flash of lightning the very second that it takes place, even if it is very far from us. However, thunder takes about 5 seconds to travel a mile. Usually, you can hear thunder if it is 10 to 15 miles away from you. Since lightning and thunder occur together, you can count the seconds between when you see a flash of lightning and when you hear thunder to determine how many miles away the storm is. For example, if there is 0 seconds between lightning and thunder, the storm is where you are at the moment because the sound of thunder did not have to travel to meet you. However, if you hear the thunder 10 seconds after you see the lightning, the storm is 2 miles away because it takes 5 seconds for the thunder to travel 1 mile. To determine how far away a storm is from you, you just have to divide the amount of seconds between lightning and thunder by 5 to get how many miles away the storm is. To test this experimentally, you will need 2 rolls of lifesavers, 2 blow dryers with low and high settings, 2 stopwatches, and a measuring tape. First, you will need to measure 6 feet away from a blow dryer on low behind a roll of lifesavers, the blue one, and 1 on high behind a roll of lifesavers, the black one. When instructed, the 2 players will start their timers and hair dryers at the same time, and when both hit the wall at their own speeds, they'll stop the timers. On your mark, get set, go. Now divide each time by 6 feet to get the amount of seconds it takes for each roll to travel 1 foot. The slow one takes 1.46 seconds to travel a foot, while the fast one takes 0.7 seconds to travel a foot. Place the rolls at an unknown distance from the wall. You start both, and then when the faster one hits the wall, start the timer. Stop the timer when the slower one hits the wall. Go! Divide the amount of seconds between the 2 by the amount of seconds it takes for the slower one to travel 1 foot. This will give you how far away the lifesavers were when they were together if the faster one took less than a second to travel the distance. The lifesavers were 2.97 feet away from the wall when they were together. This is like how lightning is immediately seen, but the thunder takes 5 seconds to travel 1 mile. The seconds between the 2 divided by 5 seconds per mile will give you how far away the 2 were when they occurred in the storm.
Thanks for watching this electrifying experiment. I wish this video could have been condensed, though it could go by in a flash. But of course, I don't want to sound stormy.